Yo, what's good, math crew? Welcome back to another episode of How to Algebra. It's your boy DJ, holla at me. Today, we're tackling solving system of equations with three variables. It's like solving a puzzle, promise, with three unknowns, x, y, and z. But don't worry, we've got the tools to crack it. We'll go step by step, eliminate one variable, then work it down to two equations, and finally solve for all three variables. It's methodical, it's logical, and you'll be solving these equations like a pro in no time. Let's gear up. Let's make this happen. Let's get it. All right, so we're going to be solving system of equations with three variables. So we have three equations, three variables. So normally what's going to happen is that you're going to make a decision on your own. So you're going to look at these problems, these equations, and make the best decision that you can, right? You just start somewhere and just start working. Typically, you can solve them in 5 steps or less. Typically, some aren't so easy, and depending if you choose correctly, right? Like the most efficient route would be in 5 steps. Now you can definitely choose incorrectly and start doing the wrong thing, and it's going to be a lot more steps. So here in these particular notes, it's kind of spelled out for you nicely on which ones to do. And then, but the process is still the same, right? So here we have 3 equations. All right. Hold up. All right. For this video, the equations are labeled out for you. Normally you won't necessarily have to do this, right? Because once you get nice, you don't have to label them A, B, and C. This is just so it can demonstrate what's happening, right? So I'm labeling them A, B, and C. All right, first, second, third, A, B, and C. All right, so step 1, we're going to choose 2 equations to eliminate a variable. Doesn't matter which ones you choose normally. Here they want us to choose A and B because they're trying to show you something very specific. So 2x minus y plus 2z is equal to 15. B minus x plus y plus z is equal to 3. So again, I strike my z's because my z's look like 2's. So that's like one of my tips. All right. So we have A and B. So why we want to use the elimination method to try to eliminate one of the variables. So notice we have to commit to a variable, x, y, or z. So when you're looking at these, ideally you want to choose, right, the variable that has the same coefficients but opposite sign. So here we have -1 and +1. All right. Normally, when you were looking, like if you didn't have all the fancy instructions, right, and you had to analyze yourself, here and here. So A and B and B and C, those would have been the 2 that I would have looked at. Those are the 2 that like stand out. So here they told us to choose A and B. Specifically for this reason, this is why. So now when we add them together, we're going to get, right, because I don't need to multiply by anything. I don't need to multiply the top by anything. I don't need to multiply the bottom by anything. So we add. So 2 minus 1 is just x, right? It's just 1, +1. The y's cancel. That's what we want to happen. 2 plus 1 is 3z. 15 plus 3 is 18. So this is a very important piece of the puzzle. X plus 3z equals 18, right? Notice it's down to 2 variables. 1 variable disappeared. Right, it got eliminated. Right, it got eliminated. So now that's step 1. So you choose to eliminate a variable. Too easy. The next step, you have to select the one that you didn't select, right? Because there were three. You chose two of the three. So we chose A and B. Therefore, C, the third equation, is the equation that we didn't choose. Now that's the one that we're kind of forced to deal with right now. So that one has to be dealt with. So 3x minus y plus 2z equals 18. Okay, now here comes the difficult part. I don't say difficult part, but like it requires some thinking for sure. All right, in step one, we canceled out the y's. So that means I'm like locked in to canceling out the y. That means I need to cancel out the y's again. Because what I want is an equation that has nothing but x's and z's. Right? Because over here, we have x and we have z. So I'm trying to recreate that again. So I must eliminate the y's. If I eliminate x or z, then this is not going to work. It's not going to make sense. Like it's going to fall apart. So I need to choose between A and B so that the y's disappear. The y's get eliminated. Right? So I have negative y right now. So I need to choose one that has positive y if possible. And it turns out between A and B, B is ideal because B has the positive y. Right? That's what I'm going to do. So minus x plus y plus z equals 3. Okay. So just so you can see what's happening here. We had to choose the one that we didn't select. Then we need to choose out of the two remaining, the two that we chose from previously, I need to pick one so that the same variable that got eliminated in step one gets eliminated right now. And that's what we did. So we chose B. Okay, the y's are going to cancel, right? That's what I want to happen. So 3 minus x, 3 minus 1 is 2x. 2 plus 1 is 3z. 18 plus 3 is 21. So here we have 2x plus z equals 21. So again, notice we have an x, we have a z. We have an x, we have a z. We are definitely on the right track. Had we chose a different letter, then this isn't going to work. Only way that this works is that the variables match up. Now, we line them up. X plus 3z equals 18. 2x plus 3z equals 21. So this is familiar territory right here because we've already done and solved 2x2s, which this is 2 variables and 2 equations. So again, we're looking to see what can we get to cancel. And I noticed right away that the 3's match. The only difference is one needs to be negative. So what I'm going to do is I'm going to multiply the top by -1. When you multiply by -1, you can simply flip the signs. So now, when we add, we're going to get -1 plus 2. Well, that's just 1. The 3's are going to cancel, right? Because -3 plus 3 is 0. Equals -18 plus 21. 8, 9, 10, 11. So this is going to be +3. So right now, x is equal to 3. That is the first piece of the solution. So x is equal to 3. Now we need to figure out what y and z are. So the moment you find one of the variables, you have to plug it back into one of the equations. I'm going to plug it into the top. So this is going to be, right, x, which is 3. Like I'm plugging it into before I flip the signs, right before I flip the signs. So x plus 3z equals 18. So this is going to be minus 3, minus 3. So 3z is equal to 15. Divide both sides by 3. Z is equal to 5. So z is equal to 5. So far, we found two variables. Well, we need to figure out what y is. Okay, so technically that was step 4, right? Step 4 was right here. So we have to plug x into one of the equations from step 3. That's what we did. So I can do so all of this. We can move down here. Okay. So that was step 4, right? Take x and plug it into one of the equations. Always choose the easiest one. Always choose the easiest one. And in step 5, from the very beginning, right? The very, very beginning, A, B, and C, we know what x is and we know what z is. So we got to choose one. Truly doesn't matter which one you choose. Pick the one with the nicest looking numbers. I like B. So negative x plus y plus z equals 3. So negative x plus y plus z equals 3. One of the biggest mistakes you're going to make is copying the problem down wrong. So we have what did I say? X is equal to 3. So second mistake you're going to make is getting confused by the negatives. So this is going to be negative 3 plus y plus 5, right? Because z is equal to 5 equals 3. So combining like terms, 5 minus 3 is 2. So then minus 2 minus 2, y is equal to 1. So y is equal to 1. So x, y, z, right? X, y, z. X is equal to 3. Y is equal to 1. Z is equal to 5. So 3, 1, 5. 3, 1, 5. Okay. I mean, that's pretty much it, right? That's pretty intense. You pick two equations so that one variable gets eliminated. Then of the 3, the one that you didn't choose, you must choose now. And now you have to make another decision. Of the 2 that you chose originally, right, you have to pick one so that it'll cancel out a variable in the third equation. So now when you have 2 2x2s, you stack those together and you eliminate them one more time using the elimination method. Whatever variable you end up with, plug it right back into one of the 2 like immediate ones that you just did, and that'll, because right, this is x and z. I'm guaranteed to get 2 variables to come out. We did x and z. And now you take the x and z and you plug it into one of the original 3 to solve for the third variable. In this case was y. I mean, it's crazy. All right, let's try it again. This time I'll work through it slightly quickly without all the explanation, just so you can see another example. All right, so we'll stick with what color are we using? Maverick blue. All right. So A, B, C. A, B, C. All right, they want us to choose B and C. Minus x minus 5y plus 6z is equal to negative 24. C is going to be negative x minus 4y plus 5z is equal to negative 21. All right, the thing that jumps out at me is that the x's have the same coefficient, -1 and -1. So I'm going to try to eliminate x by multiplying everything by -1, meaning I'm going to flip the signs of something. So I'm going to flip the signs of the bottom. You could do the top. There's nothing wrong with that. So when we add, this goes away. -5 plus 4 is -1. 6 minus 5 is +1, z. And then -24 plus 21 is -3. So -y plus z is equal to -3. That's what it is. Okay. Now, because we chose B and C, I have to choose A, right? The one that wasn't chosen. So 5A, or 5x rather, minus 4y plus 2z equals 21. I mean, if you have to, pause the video and process what I'm saying. Okay, I had to choose A. So now I have to choose between B and C because I need x's to disappear. So which x? Or which one rather? So it truly doesn't matter, but I'm going to pick B. C has smaller numbers. Let's just do C. So this is going to be -x minus 4y. Oh, that's going to be nice here in a second. Plus 5z equals -21. Well, it might be nice. Okay. So I need the x's to disappear. Even though, like right now, it's like, oh, look, the 4's match. Let's make the y's disappear. Like, no, please don't do that. Because then look what you're going to be left with. You'll be left with x's and z's. And that's trash, right? That does us no good because I need to have a y and z. We need y and z. So x must go away, right? X must go away. So we've kind of locked ourselves into x. So I need, the good thing is that one's positive and one's negative. But if -5 was on the bottom, that would be nice. Right, if -5 was on the bottom. So I'm going to multiply by 5. Everything by 5. I'm distributing 5 to everything. So this is going to be -5x, -20y, +25z, and then 2, 4, 6, 8, 10 plus 5. So this is going to be -105. Right, all I did was distribute the 5. Now when I add 5 minus, so now kind of like disregard what's in the middle. We're only looking at the top and bottom, right? Like the in red, the rewritten version. So this is going to be 5 minus 5, which is 0, right? That's what we wanted to happen. -4. Now we're adding, right? -4 plus -20. -4 plus -20. So that's going to be -24y. 2 plus 25, +27z. And then 21 plus -105. So -105, -85, -84. Okay. So this is the second piece of the puzzle. Second piece. So notice we have a y, we have a z. We have a y, we have a z. We're definitely on the right track. So let's rewrite these. So this is going to be -y plus z is equal to -3. -24y plus 27z is equal to -84. Okay. so let's pick a variable to eliminate. I like 24. Or let's do the y's. Right, I'm going to have to multiply the top by a negative, right? Because I need to make one of them positive, and we're going to do 24. Okay, so this is going to be, oops. I'm going to rewrite it. So this is going to be negative is a positive 24y plus, technically, it's going to be negative 24z, and then positive 24 times 3. 12, 6, 7. 72. Negative is a positive, so positive 72. Is that true? 4 times 3 is 12. Carry the 1. 3 times 2 is 6. Add 1 is 7. All right. So now when we add, when we add, the y's are going to cancel. This is going to be positive 3z, and this is going to be negative. So I had negative 84, and I'm adding 72. So negative 14, negative 12, right? Because I had $72 subtracting 84. Yeah, I'm 12 in the hole. So divide both sides by 3. So it's going to be 4. So z is equal to negative 4. And that's an important piece. Because right away, step 4, we're going to take z and plug it back into something. I'm going to plug it back into negative y plus z equals negative 3. That's what I'm plugging it into. So if z is equal to negative 4, we're going to get negative y minus 4 equals negative 3. We're solving for y right now. So plus 4, negative y is equal to 1. But I don't want negative y, I want positive y. So negative 1, y is equal to negative 1. Okay. Y is negative 1, z is negative 4. We got to go back to the original, the OG, and we got to pick one. If I know y and z, we could just pick b. Yeah, we could pick b. So this is going to be, b. Negative x minus 5y plus 6x. No, 6x. 6z, bro. Equals negative 24. Okay. Y is negative 1. Z is negative 4. So negative x minus 5 times y, which is negative 1, plus 6, which is times z, which is negative 4, is equal to negative 24. All right, simplifying even further. Negative x plus 5 minus 24 is equal to 24. So this is going to be, well, I can make this into 21, right? So I'm going to skip a step, right? Because I can combine on the left, but if we add 24, no, I don't want to do that. I don't want to be fancy. Let's just combine. Stick to the script. So negative x minus 19 is equal to 24. Add 19. So negative x is equal to, this should have been negative. So this is going to be negative 5. Therefore, divide both sides by negative 1. X is equal to positive 5. So x, y, z. So 5, negative 1, negative 4. 5, -1, -4. That's the solution. So again, this is a way of doing it, right? This is just getting you comfortable with the process. Choosing 2 of the 3, solving, canceling out 1 variable, ending up with 2 variables. Take the one that you didn't choose. Now you must choose that one. And now you have to choose one of the other 2 so that you cancel out the same variable that you canceled out in the previous step. So now that the variables match, you stack those up, do one last elimination. You get 1 variable. Immediately plug it back into one of the equations that you just dealt with to find the second variable. Then you take those 2 variables and then you plug it into one of the OG equations to solve for the third and final variable. I mean, that's the process. So hopefully this helps someone out. Catch you guys in the next video. Peace.